Hello students, welcome back to our class. In the previous class we discussed about nth term and what is the general form of nth term of an arithmetic progression. So, in this class we will be discussing about what is the sum of n terms of an arithmetic progression. Suppose when you are given some 10 terms or 20 terms or 30 terms, it is not that easier to keep adding all the terms to get sum of some required number of terms. So, definitely we need an explicit formula to find out the sum to n terms of an arithmetic progression. For that, I am going to take the general form of an arithmetic progression. So, what is the concept that we are going to discuss now? We are going to discuss here is sum of first n terms of an arithmetic progression. Okay. Sum of first n terms of an arithmetic progression. For that, I am going to take what is the general form of arithmetic progression. Before this, I just want to recall you one very interesting, story behind this formula. That interesting story is before 400 years, one mathematics class is going on like this. Before 400 years, one mathematics class was going on like this. So, in that mathematics class, mathematics teacher posed one question to the students. Can anybody tell or find the sum of 1 to 100 natural numbers? How many natural numbers? 1 to 100. Then every single student started taking their pens as well as a white paper, piece of paper, and they are trying to solve, they are trying to find out what is the sum of 100 numbers. How they are writing? Some of them are writing like 1 to 10 numbers, and then 21 11 to 20, 21 to 30, 31 to 40, and so on, isn't it? And some of them are started counting by fingers. So, 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and then going to the leg fingers also. But see here, most of them are taking more time to answer this problem, very much time. And after after 1 hour or 2 hours of the time period of time, and we are human, we are being humans, that we definitely do not trust on our answer. So, definitely we will see the next answer, the one who next to you. So, then we will definitely compare with our answer. If our both the answers are matching, definitely our answer is right. Otherwise, suppose if we both got different answers, then definitely I trust the one who got the answer. See, this is what the human psychology. Of course, it is interesting and funny, but here the one very interesting character has come into picture. What was that interesting character? The name of the character is Carl Friedrich Gauss. Who is that? Carl Friedrich Gauss. So, that small boy, he answered the given problem within no time. How he answered the problem within no time? What teacher asked? Teacher asked about the sum of 100 natural numbers, first 100 natural numbers. Then he answered the problem in such a way that 1 plus 2 plus 3 plus 4 plus so on, how many natural numbers? 100 natural numbers. That is why he has written 98 plus 99 plus 100. Okay. So, he just kept a name for this sum, that name is equal to some S, because he is going to find sum. And immediately he wrote the same sequence series of numbers in reverse order. Reverse order means what? 100 he wrote first, and then 99, and then 98, and then 97, and so on, and then 3 plus 2 plus 1, and then he started adding corresponding numbers. Corresponding numbers means S plus S is going to be 2S, 1 plus 100 101, 2 plus 99 101, 3 plus 98 101, and so on. Here also you get, of course, obviously 101, and here also 101, and here also 101. How many 101s are there? There are totally 100 101s are there. Then he wrote that as 2S is equal to, there are 100 101s. You want only S, right? then 2 ones 2 50s, 50 into 101 is equal to 50. Therefore, the sum of first 100 natural numbers equal to 50. He easily answered this problem, whereas the others are taking lot of time, they are struggling to get the answer. That boy's name is Carl Friedrich Gauss. So, later on he contributed to mathematics in several fields of mathematics, and he proposed so many interesting theorems also. On his name there is a theorem called Gauss theorem, right. These are all very interesting contributions of mathematician. Later on he was a mathematician, right. So, this is one of the interesting way of finding sum of first 100 natural numbers. The way that he followed, exactly we are going to follow to figure out the sum of first n terms of arithmetic progression. So, what is the sum of first n terms of arithmetic progression? That's what I am going to explain you now. Okay. So, the concept that we are going to discuss is sum of first n terms of an arithmetic progression. Sum of first n terms of an arithmetic progression. For that I am going to take what is the general form of arithmetic progression. What is general form of arithmetic progression? A plus D, A plus 2D, A plus 3D and so on. We need up to n terms, right. What is the nth term of arithmetic progression? A plus n minus 1 into D. You understand? A plus n minus 1 into D. So, I am again giving the name of this sum as S. The very first term is A plus, second term is A plus D and the third term is, what is third term? A plus 2D and the fourth term is A plus 3D and so on. How many terms I want? I want n terms. So, what is the nth term? Nth term is going to be A plus n minus 1 into D, that is the nth term. So, if this is the nth term, what is the term before nth term? It means n minus 1th term. Substitute n minus 1 in the place of n. So, n minus 1 minus 1 equal to n minus 2. So, the n minus 1th term is A plus n minus 2 times D, right. So, plus so on. This is what the sum of first n terms of arithmetic progression. And now, I am going to write this sum in reverse order. You understand? Just before this we discussed about the sum of first 100 natural numbers. The same way, again I am writing the sum in the reverse order. What is the first number there? A plus n minus 1 times D, that is the first number. And what is the second number? A plus n minus 2 times D plus so on plus last two numbers. What are last two numbers? A plus D and the last number is going to be A. So, when you add the corresponding numbers of these two series, S plus S is going to be 2S, which is equal to A plus n minus 1 into D. You will have to add these two, A plus n minus 1 into D. There is 1A is equal to 2A. Since there is no D term in this, so that n minus 1 times D, okay, plus second term to second term. See, this is first term to first term and second term to second term means this is second term to second term, and then third term to third term, and then last second term to last second term, and then last term to last term. This is the way of adding the terms. So, when you add them, see second term to second term, A plus A is going to be 2A plus this is 1D, these are n minus 2D. So, n minus 2 plus of minus 1 or plus 1 only. So, n minus 2 plus 1 is equal to n minus 1. So, that n minus 1 times D. Of course, you get the same numbers, right, we have seen in before example. So, 2A plus n minus 1 into D, here also 2A plus n minus 1 into D and so on. Here also the last term is 2A plus n minus 1 into D. How many 2A plus n minus 1 into D's are there? Because we are adding n terms, we have n 2A plus n minus 1 into D's. So, therefore, 2S is going to be n 2A plus n minus 1 into D's, right. but we want Sn only. Therefore, sum of n terms of arithmetic progression is going to be transposed to that side, then it would be n by 2 times 2a plus n minus 1 into d. This is the formula for sum of first n terms of an arithmetic progression. What is that? S is equal to, S means sum of first n terms, you can even write Sn also. So, Sn is equal to n by 2 into 2a plus n minus 1 into d. This is sum of first n terms of arithmetic progression. Hope you understand. And I would write this Sn is equal to n by 2 into 2a plus n minus 1 into d, and let us see what are the interesting facts of this Sn. Okay. So, I would write Sn, sum of n terms of an arithmetic progression is Sn is equal to, what is that formula? N by 2 times 2a plus n minus 1 times d. Okay. Sn is equal to n by 2 times 2a plus n minus 1 into d is the formula for sum of first n terms of an arithmetic progression. And then if you once observe clearly, there is a partial portion of this formula is I think it is nth term of arithmetic progression, right. If I rewrite this, Sn is equal to n by 2 times 2a, writing it as a plus remaining term is n minus 1 into d, right. See, what is this a plus n minus 1 into d? This a plus n minus 1 into d is nth term of arithmetic progression. Yes, you can write it as n by 2 into a plus, this is nth term, so an, and you can even write this an as last term of arithmetic progression also. So, that you can even use the indication Sn is equal to n by 2 into a plus l, where l is equal to nth term, which is going to be a plus n minus 1 into d, right. This is about sum to n terms of an arithmetic progression. So, sum to n terms of arithmetic progression is Sn is equal to n by 2 into 2a plus n minus 1 into d, or Sn is equal to n by 2 into a plus an or a plus l. So, when do we use this formula for sum to n terms of arithmetic progression? So, definitely there is a use of this and sum to n terms of arithmetic progression. So, in which cases we use this sum to n terms of arithmetic progression? For example, you are given 50 natural numbers, 1 to 50 natural numbers. What is the sum of 1 to 50 natural numbers? Suppose you are asked the question, then how are you going to answer that? First, you will have to check whether that 1 to 50 natural numbers forms an arithmetic progression or not. So, if they can form arithmetic progression, then definitely you can use this formula. For example, sum of first 50 natural numbers. 50 natural numbers means 1 plus 2 plus 3 plus so on plus 50 is equal to how much? So, in order to find this sum of n terms of this arithmetic progression is called arithmetic series. Series is nothing but sum of terms. So, where first term a is equal to 1 and common difference is equal to 2 minus 1 is equal to 1. Therefore, what is sum of first 50 natural numbers? You can write it as S50. S50 means 50 is going to be the value of n. You know what is the last number? Last number is 50. So, that S50 is equal to how much? When last number means A50, A50 is given as 50. So, directly you can use this formula to find out this sum. S50 is equal to what? N by 2. N by 2 means 50 divided by 2 into a plus an. A is equal to first number, n is equal to last number, right. So, which is going to be 50 by 2 is equal to 25 times 50 plus 1 is equal to 51. So, 25 ones are 25. So, 5 to 25 5s are 125 plus 2 is equal to 127. So, the sum of first 50 natural numbers is going to be 1275. So, this way we can understand what is the formula for sum of n terms of arithmetic progression. Thank you.